Hello, we're doing Chapter 7, Section 7. The title of this section is Multiplying Polynomials. So we've done some monomials times monomials, some monomials times binomials and trinomials. Now we're going to do binomials times binomials. Whew, all right. Basically what that means is I'm going to multiply a polynomial with two terms by a polynomial with two terms. Okay, so two terms times two terms. Now, like I said when I introduced this in the previous video, some teachers like to explain this using FOIL. I cannot help that. I wish I could. I'm going to show you a better way. So I'm going to make my multiplication chart, but this time I'm going to extend it a little bit because I'm going to put the x here and I'm going to put the 1 here, x plus 1. Across the top I'm going to put x and the -2 for x plus -2. Now, what I usually do is this, but what I did in the previous video is I actually drew everything in, and you saw that. Let me show you this one. You saw that when we did those. Okay? So if you want to draw all your boxes, that's fine. But just remember I've got 2 by 2, which is going to give me 4 spaces in here. What goes right here? That's x times x, which is x to the second power. What goes here? That's x times -2, and I write it -2x. In this corner, 1 times x, I can write 1 times x, but remember it's just x. And right here I write 1 times -2, which is -2. These two I can add together, so I get x to the second power. 1 plus -2 is -1. So I get -1x, subtract 2. And most of the time we're going to hide that. So I'm actually going to write it x squared, subtract x, subtract 2. Now again, FOIL is, yay, FOIL. But again, what I'm trying to do is get you to know when we have this, that we can go back to here, that you know that this is what's actually happening. Right? And when we get to the factoring part, hopefully it'll make a little bit more sense. X plus 1 squared. So I get x plus 1, x plus 1. X times x is x squared. X times 1 is just x, or 1x if you want to write it that way. 1 times x is also just x, same thing. And 1 times 1 equals 1. So I get x to the second power plus 2x, two of them right there, plus 1. And that's another example of a perfect square trinomial, which are going to be very important in the work that we're going to be leading up to, okay? Especially when we get into quadratics. Hey, here's another one. So I get x, subtract 2, x, subtract 2. X times x is x to the second power. X times -2 is -2x. We write it that way. We don't say x -2. -2 times x. For this problem, these two are the same because of that. And -2 times -2 is +4, which is a perfect square. So I get x squared, subtract 4x plus 4. And that's another example of a perfect square trinomial. They may pop up every now and then. Y subtract 3, so this one goes along the side. Y subtract 5, this one goes across the top. Oh, by the way, it doesn't matter which side you put them on, okay? I just try to be consistent because I know you guys are learning a lot of information here. So if I throw in there, hey, by the way, it doesn't really matter, then that sometimes causes confusion. Y times y is y to the second power. Actually, just the fact that I even mentioned it may have caused confusion. Y times -5 is -5y. -3 times y is -3y. And -3 times -5 is +15. And these two are like terms, so I can add and get y to the second power. -3 plus -5 is -8y plus 15. All right, now these two right here, don't be scared of them. You can do this. The skills are the same as what you learned before. 4a to the third power, 4a to the third power. negative 2 times b. A, negative 3 times b to the second power. All I'm doing is multiplying right here, what I'm multiplying on the left by multiplying above it. So 4 times 1 is 4. A to the third times a to the first, I'll put that 1 in there, is a to the fourth. Good job, you got this. 4 times negative 3 is negative 12. I have a to the third and b to the second. I can't put those together, or at least simplify them other than writing a to the third, b to the second. That's okay. Same thing with this one. I get negative 2 times 1, which is negative 2, but I got a times b, or b times a. Remember, we put them in alphabetical order. A, b. And negative 2 times negative 3 is positive 6. B to the first times b to the second is b to the third power. Let's look inside here. A to the fourth, no. A to the third, b to the second, no. None of these are like terms. So all I do is 4a to the fourth, subtract 12a to the third, b to the second, subtract 2ab plus 6b to the third, and just leave it like that. Someone usually asks the question, does the order matter? No, not really. There is, because I'm using two different variables, we're not as strict about it. But we do try to put it in what we call standard form. So we do 4, 3, 1, and this is actually a to the 0 power because there's no a's over there, right? So that's one way of doing it, but to be honest, we're not going to be too picky with that. All right, last one. I have m to the second power and negative 2m times n. 3m times n and n to the second power. I really wish they wouldn't do m and n's. Sorry, my throat's starting to get a little dry from all this talking. All right, I got 1 times 3, which is 3. I have m to the second times another m, that's m to the third power. I have no n's, but I have 1 here, so just n. M to the second times n to the second, just write it like that. I can't simplify this anyway, because those are not the same base. Negative 2 times 3 is negative 6. M times m is m to the second power. N times n is n to the second power. And in the last box, negative 2 times 1 is negative 2. M, there's no m's here. N times n to the second power, that's n to the third power. So let's look and see if any of these are like terms, having the same bases with the same exponents. M to the third, n to the first, no, no, no. So I get 3m to the third, n. M to the second, n to the second. Yes, these are like terms. So negative 6 plus 1 is negative 5. M to the second, n to the second. And this last one here, that's not like terms with anything. All right, we'll see you in the next video.